Hey all, welcome back. Are you a student who is interested to enter into design and verification domain? Then this video is for you. You all know that design and verification domain is one of the most highest paid domain within VLSI. Then if you want to enter into design and verification domain and are seeking the help from some YouTube sessions in order to learn this courses within design and verification like Verilog Systemverilog Uvm. So this video is for all of you. So while learning the course, there is always a difference between learning a course in a trained institute by joining any trained institute and learning a course by yourself by seeking information from internet and by seeking information through YouTube sessions. Yes, the main thing that differs between these two is that the course structure. Yes, it is the course structure that makes the difference. But why? Because when you enter into any institute for training, they will provide you course structure so that you can understand what are the topics that are present in the course and have we covered all the topics within the course. So all these things you need to know. So, in the same way, if you are learning through any some free resources like any YouTube sessions, or else you can go for any websites for learning all these courses, then there you might get a confusion like what are the actual topics that we need to cover within that course and what are the important topics that we need to concentrate on while attending any interviews, all these things, right? So in today's video we are going to cover all these topics like what is the course structure of design and verification domain, like what are the courses you need to learn, and among those courses what are the concepts that you need to learn, and among that concepts what are the important concepts that you need to concentrate on while attending into any interviews, right? So this is all we are going to discuss today. And before entering into today's video, if you are new to my channel, consider subscribe to my channel and also hit on the notification bell. Also, if you like this video, please do like it and please share to all those VLSI aspirants who also want to enter into DV domain within VLSI, right? So coming to the DV domain, and also I have made a separate video on the roadmap to design and verification domain, like how to enter into DV and what are the things that you need to consider before entering into design and verification domain and all. I have made a separate video on that. I'll link that in the description box. You can go there and check it out. And now coming to today's video, which is what is the courses that you need to learn. So firstly, if you want to be either design engineer or a verification engineer, you have to concentrate on certain courses like Verilog, System Verilog, and develop the test benches on using UVM. Okay, so these are the three things that you need to learn. So along with this, you will be doing some protocols. You will also learn some protocols is nothing but you will be made to learn the specifications, because that is all everything starts like when you enter into real time field. Okay, you will be designing circuits. So in order to design a circuit, you need to know how to read the specifications basically is called as spec. Okay, so either as a design engineer or a verification engineer, you will be given a spec, okay, specifications sheet. Okay, so in that specification sheet, everything is mentioned. So based on the specifications that were mentioned to you, you will be designing the circuit. So for that, you need to know how to read the specifications. What are the things that you need to consider while reading the specifications? I have already made a video on one specification, such specification like protocol, which is APB protocol. Okay, if you are interested, you can go there and check it out. I'll link that particular playlist also in the description box, okay, where I have clearly explained about entire protocol, right? So these are the things that you need to learn while learning any in order to enter into DV domain. So among that, first thing is Verilog. So you all know that Verilog is a HDL, okay, hardware description language. So among in this Verilog language, like in this Verilog, what is the syllabus? Just like that. Okay, what is the syllabus that you need to cover? Okay, either you are seeing my, you are following my YouTube channel or any other YouTube channel also. Okay, while you are learning the course, try to know whether you have covered all these concepts. Like while you are learning from free resources, try to understand, try to evaluate whether you have covered all the concepts that I am mentioning today in my video. Okay, first thing is you should know about Verilog language basics. Like what are the basics? What is the evolution? Like what is a Verilog evolution? And then what is the difference between Verilog and VHDL? So all these things, and then after that Verilog constructs is very important, like within which what are the things that we'll be covering, like data types, which are the most important thing. Within data types you are having various data types like net registers, okay, integers, so all these things. And then the continuation of that is you should know about vectors. You should know the difference between vector and scalar, and then you should know about arrays. After arrays you should know about what are operators, what are different kind of operators that you will be using in order to write a code within Verilog. So all these things you should understand, like data types, vectors, arrays, operators. Okay, now after covering all these things you will be going for tasks and functions, which is again very important topic within Verilog. Okay, then within tasks and functions you will be learning like call by functions, okay, call by reference value. So all these things you will be learning within tasks and functions, and then you will also know the difference between tasks and functions here itself. After this you will be going for what is module, which is the basic thing you should know while writing a code. Okay, so from here what you until now what you have learned, like data types, vectors, arrays, tasks and functions, these are used in order to write a code. Okay, for writing the code you should know what is the module, what is module instantiation, what are the ports, how are you going to declare the ports, what are different kinds of ports, connections, and everything you will be learning within modules and ports. So know whether you have covered all these topics like modules, within modules, module instantiation and everything. And within ports you should know what are the different kinds of port connections within Verilog. And after this we'll be coming for assignments. So in assignments basically you are having two kinds of assignments, which are continuous and procedural. Okay, basically three things, which are continuous, procedural and continuous procedural, which was recently included within Verilog. Okay, so these are the three things, like three kinds of assignments. You should know about continuous assignment, you should know about procedural assignment and continuous procedural assignments. Okay, so until now what we have covered, like everything we will be used in order to write a code. Okay, so in order to write a code we will be using different modeling techniques, right? So basically in Verilog you are having four modeling techniques, which are data flow modeling, behavioral modeling, gate level modeling, and switch level modeling. So if you are a design or verification domain, and if you want to enter into DV domain, basically you will be learning in Verilog only three modeling techniques, which are data flow, behavior, and gate level. Why is it? Because switch level is not that much important when compared to these three types of modeling. So that is why you just observe whether you have covered these three modeling techniques, like data flow, behavioral, and gate level. Okay, so among these three, like in data flow you will be learning about operators, in behavioral level modeling you will be learning about the assignments. Okay, and in gate level modeling you will be learning about the gates within gates. Okay, so these are the things you will be covered within modeling techniques. And then you should know about the FSM code. You should know how to, what is FSM, which is finite state machine, and how to write a code by using either Mealy or Murray machines. Okay, you will be writing a code. You should also know how to write a code with a in Verilog for this FSM. Okay, and then you will be learning about compiler directives. Compiler directives are also very important within Verilog. Like you will be having many kinds of compiler directives like tick include, etc. So all these things you should understand. Okay, and then coming to next is Verilog timing regions. Like basically when you are writing the code, okay, every part of the code will be executed in different parts of different regions within Verilog particular simulation region. So among in Verilog you are having four kinds of regions like active region, inactive region, NB and postponed region. So among these regions, you should know which particular part of code will be executed in which region. That is also very important. Okay, and then you will be learning about system tasks. Okay, which are like dollar display, dollar monitor, dollar strobe, dollar writes, all these things. Okay, so this is about the Verilog core structure. So while you are learning the code, evaluate whether you have covered all these topics. Now, coming to what are the important topics that you need to revise or that you need to concentrate on while entering into interviews. Okay, so when you are going to interview, basically you should mainly concentrate on topics like first thing is arrays. You should concentrate on arrays topic. Okay, and then after arrays you should be concentrating on tasks and functions, right? Yes, you should understand what are tasks and functions and what is different between tasks and functions. Like you could expect most frequent questions from these topics. Like within the arrays you will be asked, and then within tasks and functions also you will be asked the questions. And then coming to modeling techniques. Within modeling you will be asked about operators within modeling techniques. Like you will be given a logic, you will be asked to write a logic or you will be asked to write a code by you in data flow modeling by using various operators. Like you will be given a logic and you will be asked to write a code by using only one kind of operator. Like in operators, yeah, in data flow modeling you will be using lot of operators like mostly logical operators, bitwise operators, conditional operators, so all these things. So based on one logic, based on these kinds of operators you will be asked to write a code in data flow modeling. And then in behavioral modeling, yes, in behavioral modeling also the most important thing that will be asked is like what is blocking and non-blocking statements, like the execution difference between blocking and non-blocking statements. And also among this data flow modeling and behavioral modeling and gate level modeling also, one frequently asked question is about delays. So without delays you won't be having at least one question. You can expect one question from delays within among these three things. Like any delay, like in behavioral modeling delays or data flow modeling delays or gate level modeling delays also, you will be asked questions. And also the important thing is the difference between blocking and non-blocking statements and conditional statements, so all these things, right? And then the most frequently asked is from FSM. Okay, so you will be given a sequence and you will be asked to write a code by using either melee or mure, so all these things. Okay, and then you will be asked about Verilog timing regions. So within timing regions, basically as I told you, you will be having four timing regions. So among those four timing regions, you will be asked which will be executed at what point of time, which statement will be executed at what region. So in this way, you can expect the questions. And then coming to the system tasks. So among the system tasks you will be having, like as we told, four system tasks: display, dollar monitor. So from this dollar display, dollar monitor system task, the most frequently asked question will be the differences. Okay, the difference between dollar display, dollar monitor, or difference between dollar monitor, dollar strobe. In this way, the difference between the system task is the most frequently asked question, right? So this is about the Verilog language course structure and the most frequently asked concepts within that Verilog. Now coming to system Verilog, right? So many of the students who are messaging me in either my LinkedIn or in YouTube also, most of the students are telling that they know about the Verilog, but they are in a dilemma whether or not to learn system Verilog. Okay, my answer for this particular question is you should definitely go to system Verilog if you are familiar with Verilog, because when you want to enter into either design or verification engineer as as a fresher, you will be either given a designer job or else a verification engineer also. You can enter into either that domain or this domain. So for this you have to know system Verilog and UVM also in order to enter into this DV domain. So that is why learning system Verilog and also learning what is the core structure of this system Verilog also very important. So let us see what is the core structure of system Verilog and what are the important concepts in system Verilog. That also we are going to discuss. So the first thing in system Verilog core structure is system Verilog introduction. So this in this introduction you will be covering, like you will be seeing what is the why do we come to the system Verilog even though we are having Verilog HDL. Basically system Verilog is called as HVL, which is hardware verification language. Like what is the difference between system Verilog and Verilog? You should definitely know this. This is also most frequently asked question. Yeah, when you see any differences between system Verilog and Verilog in internet, you can find many differences. But your understanding on why do we have come to system Verilog even though we are having Verilog is important there. Okay, so for this I have made a separate video on detailed discussion about this difference between Verilog and system Verilog. I'll also link that in the description box. You can go there and check it out if you need it, right? Now coming to system Verilog, the first thing is SV introduction, and then the remaining concepts, like if you see here system Verilog, as you already know, if you don't know that, system Verilog is an extension of Verilog. So what are the topics that you learn in Verilog? You will have a discussion in system Verilog also, which are operators, data types and arrays. Yeah, data types and arrays and operators are present in Verilog also, but in system Verilog, along with the data types, arrays that are present in Verilog, you are having many more other kinds of data types and arrays within Verilog. Okay, so you should also learn that. And then procedural statements. Basically, procedural statements are same in Verilog and system Verilog also. And then tasks and functions. Tasks and functions also mostly same. Like in Verilog, what you have learned, those are topics only you will be present in system Verilog also. Okay, so that is why in Verilog you have to concentrate mostly on these things so that it will be easy for you to understand when you come to system Verilog. Okay, and then processes. Processes is very important. This is where actually you will be starting the actual system Verilog course. Okay, until now what are the topics that you have discussed, like data types, arrays, even though you're having some extra things within the system Verilog, but the actual basics are same as that of Verilog. But when it comes to processes, okay, like fork join, any fork joiner, so all these things you will be learning within system Verilog. Okay, even though you these are generally when you see the Verilog structure, some will be presenting about this fork join, but you will be knowing about this in detail in system Verilog itself. Okay, so and then the most important thing is oops concepts. So like object oriented programming concepts, so within this you have to follow this order. Like first you should know about basics of oops, like you should know what is class, what is object and what is handle within that particular thing. And then you should know what are the properties and methods within the class, and then you should know how to copy these properties and methods. After this you will be learning about inheritance. So after inheritance you should know about casting. Okay, basically you can learn cast either learning all the properties of oops, or you can learn after inheritance also. Okay, and then you should know about encapsulation, polymorphism, okay, and also abstraction, Basically, when you are learning about this castings or else some static and dynamic casting, you will understand what is abstraction, which is also one of the important property, and then static properties and methods, and then scope resolution operator. So these are the things that you should concentrate on when you are studying about the oops concepts. And then coming to constraints and randomizations. Okay, this is also very important. So you are having lots of constraint types, which presently I am discussing in my channel. Okay, there we'll be discussing about all types of constraints within system verilog and randomization constraints. This is very important. And then interprocess communication, like you will be seeing concepts within this like semaphores, mod ports, clocking blocks, virtual interface, event and SV regions. So all these things we'll be discussing about this in this interprocess synchronization. And then after this we'll be going for assertions. So in assertions we'll be covering topics like what are the assertions format, like how do we write a assertion, and what are the built-in methods within assertions, like already what are the built-in methods that are present in assertions, how can we use operators within assertions, and what are variable delays. So all these things we'll be covering within assertions. Okay, and then functional and code coverage. So basically you will be asked what is functional coverage and what is code coverage. Among code coverage also we are having different types. We will be discussing all these things within the functional and code coverage, like coverage topic. And then you will be having configuration libraries and packages. And then after this basically we will be knowing what is the package and everything here. And then functional verification overview, like you will be developing the test bench. Okay, like you will be writing the code and writing the test bench code for that particular RTL in SV format. Like based on the SV architecture and based on the components, you will be developing your test bench and you will be writing the code. Okay, so this is all. Like after that, we will be just giving the course overview on every concept within this particular system verilog. Okay, so these are the things you need to cover when you are learning system verilog. Okay, so and also one important thing is, if you are familiar with verilog, then it is okay for you to revise it within 1 or 2 days. But if you only know verilog and if you are not familiar with verilog, then you couldn't do it in 1 or 2 days. You should at least take 15 to 20 days. According to me, it will be 30 days minimum in order to understand every topic clearly. Okay, so that is why if you are familiar with verilog and if you think the system verilog you can do it in 1 or 2 days, it is not true. Okay, you because apart from verilog, system verilog is having many advanced features. So in order to enter into any interview or in order to give any interview on system verilog, if you are a verification engineer, you should definitely understand system verilog, because system verilog is heart of verification engineer. Okay, if you don't know system verilog, you can't develop the test bench. If you can't develop test bench, that means if you can't write a test bench code, simply speaking, how can you verify it? Okay, so that is why system verilog is that important within this part. But if you are familiar with system verilog, then you can happily understand this about UVM in 1 or 2, maximum in 10 days you can understand it clearly. Okay, because whatever concepts that are present in system verilog, you will be applying it in universal verification methodology. This universal verification methodology is not a language, it is a methodology. Means whatever concepts that we are learning in system verilog, by applying those concepts you will be developing the test benches here on particular circuit in UVM. Okay, so in UVM, what are now coming to system verilog, what are the important topics that you need to learn if you enter into any interview is because is basically, first, you should know what will be the difference between folk join any, and folk join none. Okay, try to execute various codes related to these three things. so that you can understand the difference between fork join any, and fork join none. And then you should understand OOPS properties, mostly the four properties. You should be clear with these four properties, like where to use, when to use, and what is the difference between one property and another property. OOPS is all about these four properties, which are inheritance, encapsulation, abstraction, and then um, polymorphism. So all these four things. So I have made a separate video on all these four at one shot. Like, in order to know the clear difference between all these four, I'll link that also in the description box. Those who are interested, you can go there and check it out. And then coming to the oops, among oops, these are the four things that you need to consider. And then coming to constraints and randomization, like among this constraint and randomization, what is the thing that you should revise while you are attending interview is that constraints. You should know how to write a constraint, because within constraints you are having many wide variety of constraints. Okay, you can write a constraint by using any kind of way. So that is why you should know what are the ways in which you can write a constraint. Okay, so basically when you enter into any interview, you will be given a logic. Okay, you will be asked to do randomization on particular variable, but you were asked to randomize it by using some limitations. Okay, so that limitations is nothing but how we will be randomizing it, by putting some limitation to it, by using the constraint. That means you should write a logic in such a way that it will be putting the limitation for randomizing that particular variable. So that when you understand, that when you are going to write it, when you understand, okay, I can write the constraint by using this particular, because in constraints you are having lot of varieties. Like basically you can use if else condition within constraint, you can use conditional operator within constraint, you are having similarly, you are having implication operators. Okay, so in this way you are having lot more varieties, like you're having soft constraints, unique constraints. So you should know what is what in order to put this limitation. That is why without constraints there won't be any interview question. So that is why constraint is very important topic. And then after constraint, the most important frequently asked question is about SV regions, because we have already discussed about Verilog regions. Like in Verilog, while we are discussing there, I have told you that in Verilog you are having four regions, but in System Verilog you are having total of 12 regions. Okay, by because why is it? Because in Verilog you will be designing only simple circuits, but by using System Verilog you will be designing the complex circuits. Since the complexity is being increased, that is why the way in which the particular code will be executed should also have some limitations. Okay, so in order to do this, the System Verilog regions are divided into 12 instead of 4. So System Verilog regions, among the System Verilog regions you will be asked questions. And then the most frequently asked questions is about virtual interfaces. You should know what is interface and what is virtual interface. Interface is really important in System Verilog, because basically when you see the Verilog test bench architecture, you will know what is the importance of interface. Okay, it is just like a bus which will be carrying all the signals from test bench to DUT. Okay, so that is why interface is very important, and also you should know what is the difference between interface and virtual interface. Okay, so in interface you will be asked, most frequently asked question will be coming from interfaces also. And then about assertions. Okay, in assertions also you will be asked, just like how you will be asked in order to write constraints, similarly you will be asked to write an assertion. Okay, assertions means you will be asked like what is, you should know what is assertion, and you should know how to write an assertion. Okay, because you will be asked to write assertion. Okay, they won't be asking any theory questions on assertions, but you will be asked to write a assertion. How to write? They will be giving you some condition, and based on that, you will be writing the assertion for that particular thing. And then coming to functional and code coverage. So Among this, what is functional and code coverage? So basically you will be asked to write what is the functional coverage, what is the code coverage. Okay, so for this, basically when you are a fresher, you will be get less questions from these coverages. So you are just asked theory like what is this code coverage, what are kinds of code coverages within this, and so you will be asked in that way. But if you are experienced one, you will be asked in it in a different manner. So based on your experience, your questions will differ when it comes to this functional and code coverages. And then coming to the remaining things, if you see, these are just basic things like test bench architecture. So all these things, these are just in order to know how are you going to write a code within, how are you going to develop a TB code by using the system verilog test bench architecture. Okay, so these are the things you should consider while you are learning the system verilog course. And then coming to UVM constructs. Okay, basically in UVM you will be learning about what is introducing UVM, and what is the evolution of UVM. Like before UVM, what are the methodologies that were present, and then you will be learning again about OOPS basics, which is already present in that, and then UVM test bench hierarchy block diagram, which is somewhat similar. Like mostly when you are developing the test bench, you will be using the UVM architecture itself, UVM test bench hierarchy block diagram, and then you will be learning about sequences, okay, and also configuration dbs, database db means, okay, resource databases, so all these things, and UVM phases. And then different test bench components. Yeah, like you will be writing the code on monitor, on driver, on agent, on coverage. Like every particular component within your test bench architecture will be having certain code which is reusable and certain code which is not reusable. So in that way you will be writing the code on monitor, on driver. You will be learning how to write a code on all these things. And then UVM callbacks and TLM ports. So these are the things that you will be learning within UVM. So among this, what are the things that were most frequently asked is that it will be about sequences. Okay, so you'll be asked about what is the virtual sequencer, what is the difference between virtual sequence and virtual sequencer. Okay, and among this again, what is the difference between P sequencer and M sequencer. So all these things you will be asked. Among this, the frequent asked questions is on sequences, virtual sequence and virtual sequencer. Okay, and then about UVM phases, like what are different UVM phases that are present. Okay, like because in UVM phases you are having lots of phases. Okay, so among these phases you will be asked, on these phases you will be asked questions. And then the most thing is to develop, you have to develop a test bench code in UVM. Okay, that means you should be able to write a code. You will be asked to write a code. You won't be asked to write the entire code. Okay, but you will be asked to write the driver code, like how the code will be in driver, like how the code will be in monitor, like how the code will be in agent. Okay, again in agent you will be having active agent and passive agent. Okay, then you need to know, and how the coverage, how you will be writing the code for coverage, and what is the work of scoreboard, how you will be going to write a scoreboard code. So all these things you were asked to write. And then about UVM callbacks and TLM ports. TLM ports is also very important. Okay, so this is about the UVM. So this is how the course structure should be when you are learning a design and verification courses like Verilog, System Verilog, and UVM. Also, along with this, as I told you, you should understand at least some two or three. You should know how to learn some specifications like APB protocol and then AXI. Okay, AHB is not that important at present scenarios. Basically, you should know, since if you are a fresher, you should know about APB protocol and you should be able to understand AXI protocol. These two are very important protocols. And then along with this you should know certain tools like Linux tools are very important. And then after this, if you understand all these things also, and if you are if you still want to learn something, then you can go for certain scripting languages like pearl language. Okay, so so that it will add some weightage to your resume. Your resume can be easily shortlisted if you learn these certain languages like pearl scripting languages, because nowadays they are also in demand. Like since verification in verification also you were asked some scripting languages like pearl, that is why if you want to learn, you can learn the pearl language, which will be adding more weightage in your resume. Okay, so these are the things you should learn in order to enter into design and verification domain. Okay, so you should remember one thing: since the pay is high in this particular domain, in such a way you need to be skilled engineer in order to enter into this particular domain. Okay, you have to, while you enter into your first year itself, you have to plan in this way in order to enter into. While doing your courses itself, you have to plan for your future by learning these courses either online or through any trained institutes. Okay, so that you could, and as soon as you complete your final year, you could easily have an opportunity in order to enter into this design and verification domain. Okay, so all the best from my side to all the students who want to enter into DV domain. And among this particular courses, I have made a clear I made all the videos related to this Verilog language, and I have collected all these videos into a single playlist. I'll link that playlist in the description box, where I have almost covered every topic that I have mentioned in this course structure. And I also have preparing system Verilog also in such playlist, because recently some of the students are asking me that the system Verilog playlist is not that full fledgedly designed in Verilog way. So that is why I'll work on that also. Okay, before leaving this video, please do like this video and also share this to all those VLSA aspirants. Thank you all.